Okay, so thank you very much for having me again at the conference, and thanks to Bobby, Ronnie, and Opal for organizing everything amazingly well, as usual. I also want to say special thanks to Sri Venkatachari, who is an undergrad at UFM joining Goldman Sachs, who helped me set up a bunch of simulations for this discussion. Okay, so I thought this was a hard discussion to hold because the paper is so good. Now it became even harder because Luke explained the difficult things already so lucidly clear. So I'll jump over a few things. But I do want to point out why this is an important paper to be written. So Burke and Green here, BG, gives us theoretical explanation why you can have investors chasing returns rationally, although there's no performance persistence. Okay? Now the crucial ingredient to that model is that there's decreasing returns to scale at the fund level. So if in fact there are no decreasing returns to scale at the fund level, all these questions are up for grabs again, whether fund flows are rational, whether performance really should be persistent in this context, and so forth. So it is a very important paper to write. And of course, as Lou pointed out, the usual estimates of the fund level returns exhibit one bias or another, which is why they come up with a solution called recursive demeaning, which does give an unbiased estimate of fund level returns to scale. Okay. Now the key findings are that there's insignificant evidence of fund level decreasing returns to scale. Now I'm not sure whether the emphasis is on there is a negative point estimate, but we can't get it to become significant, or whether the emphasis is on we cannot find significant evidence, so there is none. What is clear is that there's significant evidence and much larger in magnitude of industry level decreasing returns to scale, which is new and interesting and important. So when I first read this and talked to Francesco, I said, wait, how can that even be? What's the story? And so one way how I thought about it that I thought made sense to me is, if your story is Burke and Green, and you run into a market, you detect mispricing, and you throw your capital on that, the mispricing goes away. Which is why, if you run a larger fund, you need to find more mispricing. And with your limited time and mental resources and so forth, it's going to be harder to deliver the same amount of outperformance if you run a larger fund. Okay, so this story makes sense. How could it be true that there's industry level decreasing returns to scale? And there I'm thinking, well, so if nowadays you find a new pricing factor and you program your computer to do all the trades in all kinds of different markets in order to exploit that mispricing, then really the only constraint that you're facing is how many people there are to exploit or how many people to trade with. Okay? So, and as Luke pointed out, these two things are not mutually exclusive, they could both be true. I will later point out that this suggests that there's a time series change in the coefficient, right? So as IT becomes available or technology changes, maybe the fund level decreasing returns to scale will change. And this is going to be one of the comments that I'm going to make. Okay? So the third main finding is that skill, so the ability to outperform a benchmark before the decreasing returns to scale kick in, decreases with fund age, and the explanation in the paper is this is probably because the smarter managers get added to the industry. Now notably, what is not featured in the explanation of the paper so far is that also worse managers might get replaced with other managers, and you pointed out in your robustness checks that you're working on that. Okay, so to sum up, this is a very valuable contribution to the literature. It's very important, it's a very important question, and the implications are really large. So this is a definitely worthwhile exercise. Now, comments. I want to start with talking about what the null hypothesis is for the estimate of fund level returns to scale. There's some confusion in the literature about how to address this, and I want to explain it. I will not spend much time explaining the biases because Luke already did. And then I'm going to talk about a simulation that is similar to the one that they set up in their paper with some minor quirks and address a few points with that to see how far I get. Okay, so what is the prior? Now, the authors do explain in the paper that there's a very common misunderstanding of the Burke and Green paper. So one example is by Elton Group Blake. They say Burke and Green argue that there's no predictability. Or in other words, fund size will be uncorrelated with future returns, thereby frustrating the attempt to somehow relate outperformance to fund size. Okay? Now, these statements are true in the following sense. To the investors who at time t try to forward predict returns, these statements are true. You cannot use fund size to predict future returns at time t looking forward. But it is not true to an a metrician who has a whole data set at his exposure, available, and can run the type of regressions that they run. Okay? So as a conclusion, if there are, in the real world, decreasing returns to scale at the fund level, you should also see them in the data if you use an unbiased estimator. Okay? And this is the huge confusion that plagues the literature in addition to the biases that are wrong. Okay? Now, as I said, let me jump over this. There is an omitted variable in the usual OLS. If you throw in fixed effects, the usual bias goes away, but you're introducing another one. Luke explained it. Let me jump over that. Okay. The RD estimator Luke explained as well. You recursively backward demean all the variables. You recursively forward demean the other ones. You implement this instrument with two-stage least squares. I don't have anything more to say than what Luke explained. Okay. So this estimator is going to be bias-free under the assumption, correct me if I'm wrong, that the unobserved variable, the skill, is actually constant over time. Okay? So and I think it would be great if you could discuss what happens if this thing actually does change over time, as you know your other results kind of imply, or what happens to the bias of this estimator. This is the first comment. It's not part of the comments that I'm listing. The other concern that there might be is power. You need an enormous amount of data to make this estimator stable. And you know, in light of this concern, you have to think about again: is the main result that there's no significance in this estimator, or is the point estimate really the main conclusion of it, that an unbiased estimate gives you negative point estimates? So it's just a question of discussing this and framing it in the right way and help the reader with that. Okay, so all this econometrics is kind of really hard for me to think about, and I used to be an engineer, and the solution we have for that is running simulations. So I'll generate myself a world in which I know whether there are decreasing returns to scale at the fund level. Okay, that would be this guy. And in which I know whether there's decreasing returns to scale at the industry level. So I know how this world actually works. And then I run the different regressions with the RD estimator on it, and then I can check whether it's biased or not. Okay? So in general, I have much less observations than PSD in their data, of course. And I'm using most of PST's, that's these guys, parameters. Okay? One thing that is different in what I'm doing is that if, according to the market's beliefs, a manager has more than 2% less skill than his benchmark, I'm going to replace him with a new draw from the lottery, some normal distribution of skill. Okay? So in my simulation, there is going to be replacement of managers, or which does not happen in their case. Okay? And my industry doesn't grow; it's constant over time. This is different. Okay? Then I'll just vary the true decreasing returns to scale or returns to scale. Sometimes make them 0, sometimes make them negative, both at the fund and the industry level. And then see what happens to the bias of these coefficients. So, comment number 1: the RD estimator is unbiased. The question is, for what is all unbiased? Okay. So what I'm running here is a simulation where there are fund level decreasing returns to scale, and there's no industry level decreasing returns to scale. Okay. So if this estimator works, it should, for fund size in all specifications, pick up a significant negative coefficient, and you see it reliably does that, so that's good. Okay? You should also see that at the industry size, in the true world, there's no decreasing returns to scale. There should be no significant coefficient, and indeed, that works out. You don't see any significance here. That's also good news. Okay? Now, I'm going to leave that there is fund level decreasing returns to scale, but introduce industry level decreasing returns to scale on the next one. So here it is. The true B is minus 0.2. And you see that the fund size coefficient continues to be significantly negative. And the industry size coefficient is also negative, as it should be, and significant. The only thing that I'm a little wary about is that the point estimate fluctuates around a little bit, depending on which specification I throw in. Okay, I'll comment on that in a moment. So next what I'll do is the same two tables again, but without fund level decreasing returns to scale. Okay, so now there's no fund level decreasing returns, and no industry returns. First thing, at the fund level, This kind of looks significant, but this is more like a numerical thing. But mainly the point estimates are essentially 0. Okay, so that's basically good news. And the industry size coefficient, there shouldn't be any, and indeed there is none. Good news. If there is industry decreasing returns to scale, again the estimator does pick that up. And again it fluctuates around a little bit. Okay? So now what do I conclude from that? So first of all, it always picks up the correct size coefficient. So yes, we do find an unbiased estimate here. That's good. The industry size coefficient is kind of in the right ballpark, but when I throw in more controls than what they do, it kind of fluctuates around. And then I look at the paper, and actually there's no formal claim that the coefficient on industry size is unbiased. Okay? Now there's very good theoretical reasons to believe that it is an unbiased estimate, but it would just be useful to show that in your simulation. So my strong prior is that just my simulations are off, or I don't have enough data, or whatever it is. It would just be great to discuss whether the other coefficients that you're showing in your RD estimate are unbiased as well. Okay, second column, fund age versus manager tenure. So fund age is not the same as manager tenure in a fund if the managers get replaced once in a while. Or if you get people, you swap 2 managers across 2 funds. Fund age stays the same, but manager tenure gets reset, okay? And of course, it would imply a huge friction in terms of the dollar amount you lose if you didn't put the most skilled managers in the largest funds, okay? So therefore, it seems that this must be going on in the data. And these are actually 2 lines in my regressions. I'm showing you exactly the same tables as previously. You see that when you throw in fund age, you get a significantly positive coefficient. But as soon as you split it up between fund age and manager age, everything gets picked up by the manager age, which here means manager tenure. Yeah? So everything is on the manager tenure side, which leads to higher returns. So those guys that survived and did not get replaced, yeah, they are the smarter guys because of selection here. Yeah? And fund age itself, so the age of the fund doesn't matter itself. And this continues to be true when you include industry decreasing returns to scale. You do get a significant positive effect on fund age, but only as long as you don't introduce the manager tenure. So this split seems important to me. You already pointed out, you either have to control for these things separately, or what I understand you're already doing, that's not yet in the paper, that you look at manager fixed effects instead of fund fixed effects. So I think that's a very important thing to do. Number 3. So I like your narrative. It makes perfect sense. The narrative goes, there's decreasing returns to scale at the industry level. The new managers are smarter, but they're unable to outperform because the industry size grows at the same time. Okay, that makes perfect sense to me. Now, what I wondered is industry size just growing exogenously because, I don't know, people come up with money and throw it in there? Or is it that the increased manager skill is actually the reason why the industry grows? Okay? And I think that's just an interesting question. And it is related to the biased freeness of your estimator in the sense that you're assuming that it's an exogenous variable, and has nothing to do with manager skill, I suppose. But other than that, it's just an interesting question that you may or may not want to address. Number 4. Could there be some omitted variables in this regression that matter? And they might matter if they violate your exclusion restriction. Okay? So one idea is, you mentioned in your conclusion that we control for 2 business cycle variables, but more could be explored. So I thought, okay, let's come up with a story. So here's the story. At time t-1, there might be flows into the industry. So people withdraw money from their savings accounts, put it in mutual funds. And this will affect market returns shortly thereafter, because now the mutual fund managers sit on all this cash and need to somehow put it in the stock market. Okay? In which case the flows at this time would predict time t returns, and I think your exclusion restriction might suffer. But correct me if I'm wrong here. Now, this matters because funds with better returns at t-1, possibly for random reasons, are going to experience higher flows and have to invest more money, and therefore experience a higher increase in their returns at time t. So persistence still then implies a relationship between fund returns and past industry growth. And this is the last 3 things that I'm doing here. I'm throwing in industry growth interacted with market returns last period, industry growth and market returns. And you see that industry growth does pick up a significant positive effect in this case, which so far just tells us, yeah, there's a story, but when you look up there, that's the industry size coefficient. This is actually what makes it fluctuate, what we saw previously. So I'm wondering, so if I throw in all these controls, is the industry size coefficient still unbiased? Okay, so first I thought that's a problem with this regression until I figured, wait, industry growth really is a bad control here. I shouldn't be allowed to throw that in this regression because industry growth leads to the higher industry size, so this is an intermediate variable bias. So what I conclude from that is really just, actually, throwing in these macro variables is really hard, econometrically correctly. So it might be a good idea to leave that to future research. So basically, that was my attempt of poking exclusion restriction, but I don't really know how to. So okay. Last points. Two of them. I already mentioned when IT becomes available, maybe the fund scale coefficient changes over time. That would be a super simple thing to address. In principle, now the problem is that they might run into small sample issues because you need so much data for this RD coefficient to pick anything up. But maybe you'll find something and that would actually strengthen your story. If there used to be fund level decreasing returns to scale, but they go away as IT becomes available. And the second thing is, I'm thinking that this industry scale coefficient really should change with industry size. So when industry size is only 2%, and you have 98% of the investors to take advantage of, then I can't really see how that matters whether it's 2 or 3%. I can see how it matters when the industry size becomes larger, especially according to your new proxies. And that would also just strengthen your story if you explore that. So to summarize, this is a really great contribution to that literature. And I left my commentary, we need to add more superlatives to this paper. It's a great one, and I learned a lot from it. Suggestions? I'd love to see this more simulation results in which you show under which conditions these estimators are unbiased, and not only the fund level decreasing returns to scale, but also the other coefficients that you could throw into these regressions. And definitely you should distinguish between manager tenure and fund age, and I understand you're already working on that. The harder ones is to discuss the causality of increased skill and increased industry size. That might be a paper in itself. It might be hard. What might be harder is to explore the omitted macro variables. So I understand if that is not going to happen in this paper. And the nonlinearities and time trends is the last one. I conclude this is a fantastic paper. You should all give it a read. I learned a lot from it. Okay, thank you very much.